Hello and a really big warm welcome to this presentation from the Urban Penguin. My name is Andrew Mallard and today we're continuing with topic 1.4 of our Python Certified Entry Level Programmer, and we'll be taking a look at our unary and binary operators. These are really simple, but you just have to be able to understand the terms. Once we've done that, we'll be taking a look at some of our Boolean expressions, so understanding true and false, and looking at and, or, and not. Finally, we'll be taking a look at some of our comparison operators. Come on, let's take a look at this. Now we're going to start off this journey by taking a look at unary and binary operators. It's really just understanding the terms. What they do is really quite simple. A unary operator works against just one number. For example, I could have positive 5. Now, of course, the positive value is always assumed, so we don't need to put it in. On the reverse of that, though, we could have a negative number, so negative 5. And of course, we have to supply the negative unary operator. Unary, it's just working on the one side of your argument. When we compare that, though, with a binary operator, if we do 5 plus negative 5, the plus or the addition symbol here is working as a binary operator. It's joining two halves of our equation together, 5 and negative 5. And of course, the answer results in 0. But we also have different types of unary operators, and we can start looking at some of our Boolean values. So if we have the variable a is assigned the Boolean value of true, we could set up b to be not a. So not in this case is a unary operator. It's only working against the variable a in this case. So very much like the negative symbol, we're choosing this to be not the value of a. And when we check a is true, and of course, not a is going to be false. Now, we've already looked at some of our Boolean expressions, and that was the not expression. But additionally, we have and as well as or. So let's take a look at those. Where we were using not, we could specify that the variable b was not the value of a. So with Boolean values, if a was true, b was going to be false. And we were saying that not was a unary value. When we look at c, we can have the variable c is equal to a and b. And in this case is a binary operator, where it's taking two expressions. Both a and b will need to be true for c to be true. And when we look at this, because b is false, a and b are not both equal to true, so we can see then that c becomes false. Whereas if we use the other Boolean operator or, we could have a or b. Only one of them needs to be true, and of course a is true, so c is also going to be true. Boolean expressions just return a simple true or false and are great comparisons. Let's go through and in our Jupyter notebook, create a couple of variables. We'll keep it simple for the moment. We can have an x variable with the value of 20. And why don't we create another variable y with a value of 10? So we're using the assignment operator here to assign values to our variables. With those done, if we go through and look at printing the result of our expression, and we can test for x being equal, so the double equal is looking for equality. Is x equal to y? And of course they're not, so it returns false. Whereas if we looked at another expression, maybe printing is x greater than y, this is going to return true. You can see why I say these are great when we're looking at testing conditions. We can get a simple true or false coming back and deal with that as required. You've already had some glorious experience of our comparison operators in our previous clip, but let's look at it in a little bit more detail now. We can see on line 24 we were testing for equality with x being equal to y, and on line 25 we're testing for x being greater than y. But of course there are more comparisons than that. When we go through and take a look at another one, we could actually join the two of them together. So having x being greater than or equal to y. The key here is or, greater than or equal to. Well, it's not equal to y, but it's greater than y, so it prints as true. But let's try some other comparisons. What about comparing y to be less than y? Well, y can't be less than its own value. So let's go through and look at the evaluation of this. It should come back as false, and true enough, it is not true, it is false. Okay, well, what if we play around then with printing the comparison of x being less than or equal to y? With this, y is equal to y, so the comparison is going to print true. It's not less than y, but the or in here, less than or equal to, comes in and saves the day to give true. Let's go through and just take a look at one more example. Let's test for x not being equal to y. Using the exclamation mark, we have not equal. And of course, x is not equal to y, so we print out true. So this gives you an idea of some of the simple comparisons that we can do. But if I add in another cell, just put it to raw, we can look at the comparison operators. So is equal, the two equals sign, not equal, are greater than or equal, less than, and less than or equal to. So these are the comparison operators, and these make great tools within your Python toolkit. We have looked at some simple examples, but let's now look at a practical example that might help you a little bit more. So we left off, we know now our comparison operators, but we also know some of those Boolean expressions that we can create. Let's have a variable, we'll call it age, and we'll set the age to be 25, so somebody's age. We could then test perhaps for different types of members. So what category do they fit under? We can have is young adult, and we can set this to be true or false based on the age being greater than or equal to 18. So if they are 18 or over, and their age is less than or equal to 30. So if they're between 18 and 30 inclusive, then they're going to be classified as a young adult. Obviously, at an age of 25, this is going to be a young adult. However, we can test this programmatically. If we go through and take a look at printing our variable is young adult, then we should see that it comes out as true. So there is no real difference to what we were seeing before, but we're now putting some practical words behind our variables and some proper tests. So this is in fact a young adult. But we might have other categories of members within our establishment. It could be a library or whatever. It doesn't really matter. So we can test for those as well. We could test for being a minor, and obviously we could look for being less than 18. But another way, and maybe not the most obvious way, but to look at some of our unary operators, we can then specify that not, and then our condition in parentheses, age being greater than or equal to 18. We're looking for people that are less than 18. Once we've understood that, suck that into our brains, we can allow it to execute. When we check the output then of printing is minor, then this should come out as false because we already know that the age is 25, so they are a young adult, they're not a minor. We also might have some age conditions that we don't want to include in our membership for whatever reason. We might say is out of range, so it's not a valid age. If the age is less than 10, or age is greater than 100. Remember, these are binary operators when we look at or, whereas the not was a unary operator. We can run our test on this. Let's print out the variable is out of range. And again, we know that this is going to be false because we already know that it's a valid age of 25. Now, working with one age is good, but obviously I'd keep needing to go back and change the age to see that it's working the way that I need it to. A way of having multiple ages is to have a list of ages. Now, for this particular topic, we don't need to look at lists, but there's nothing stopping me creating a list of ages. So let's go ahead and do this. This will help you later down the track in any case. And we can set up a list. Let's call it ages, plural, equals. To denote a list, we use the square brackets and separate our entries using commas. Our entries can be numerical values, Boolean values, or string values. But we're going to be putting numerical or integers in. So we've got 18, 17, 21, and let's put 31 in. You could test this again yourself by using any of the ages that you wanted to put in the list, or have a longer or shorter list. It is your practice time. With this done, we can process each one of our ages. So we can go through for age. So we're creating a temporary variable called age that we pick up from the list one item at a time. So first of all, we're going to process 18, then 17, then 21, and then 31. But we're going to print out and then we can go through and open up our parentheses. We're going to use format printing, so we're going to have our F string, so we can include text and code together. Is young adult, colon. So this is my text or string that I want to print, but then I need to put my brace brackets to allow me to print code. And I'm just going to grab the code that we used before, paste that back in, close off my brace brackets to say that the code has finished, closing off the F string, closing off the parentheses, hitting return twice so I'm returned to the correct indent level, and executing the code. We can see then, is young adult an 18-year-old true? Is young adult the 17-year-old false? The 21-year-old true? And the 31-year-old is false.
All that is left to say is thank you for watching. If you've enjoyed this, then you are probably sadder than I first thought. For more of this drivel, please subscribe, like and comment to @TheUrbanPenguin.